session. That's 3D coordination for improved project forecasting and reduced rework. Today, basically, what we are going to discuss is all about the fundamentals of 3D coordination process, clash avoidance, clash on cloud and web-based. The topic definition of 3D coordination. As an industry, many of us know what is the 3D coordination process and how it is affecting our industry. One common accepted definition for 3D coordination as a process in which the 3D coordination software is used to identify the 3D geometric conflicts by comparing 3D models of building systems. The goal of 3D coordination is to eliminate field conflicts and coordination issues prior to reach construction and installation stages. Basically, the 3D coordination fundamentals. The aim of the 3D coordination BIM use is not to identify the modeling mistakes made by the modelers or as designed physical interferences, but to focus on the design discipline coordination issues. That is, to resolve the clashes due to the conflicting design constraints, not apparent or resolved during the design itself, and to facilitate the coordination meetings, design, decision making, and model modification instructions to one or multiple disciplines in order to solve those coordination issues. And the 3D coordination is a cycle of three main events. First one is the clash detection on a merged federated project master model. Then the clash resolution by the project teams, and finally the model update. So this cycle continues till up to a time where all the clashes has been removed from the project. And in the big picture, if we are breaking down this concept, it consists of many other subcomponents as well. Starting with the preparation of models for clash detection, transferring the models in a shared project folder, then to clash detection process to be performed, analyze the clashes for the identification of real coordination issues, to categorize clashes. That means grouping clashes that belongs to one coordination issue or one coordination subject. Next, to prioritize the clashes to be discussed during the coordination meeting and to be corrected straight. Then assign model correction tasks due to the modeling mistakes. To setting coordination meetings to discuss the real coordination issues, and assign model corrections tasks according to the model coordination meetings outputs, then to a model correction done by the project team, and finally it will reach again a second set of preparation of the updated models for the next set of clash test and further on. The basic characteristics of 3D coordination, basically it consists of two vital steps. The first part is the creation of settings for the clash avoidance, and next to that there will be an inevitable clash detection process. So basically the project manager of an industry starts the process for the clash detection. He initiates this process, and the clash avoidance part consists of creation of defining 3D coordination standards and performing model authoring and performing a discipline-wise model QA/QC checks before compiling the models to in a federated format. Then starts the process of the clash detection, which includes the configuring clash detection settings by assigning the clash templates required for, and then to perform the clash detection, and to the perform clash resolution. And this cycle continues in a repetitive fashion until the clash issues has been resolved. And once it is done, the project model will be archived as a coordinated project file to end this process. So basically, 3D coordination is a process in which models from multiple design disciplines are combined and used by the project stakeholders to identify and resolve spatial coordination issues. It is an iterative process that begins early with the design and the construction phases. And why it is important? It is all because multidisciplinary and multi-organizational projects are complex and require coordinated efforts to see viable returns on the effort invested. 3D coordination on a BIM software offers both predefined and customizable modeling environments and uses standardized building components that facilitates the development, transmission, and connection of building systems in a 3D. So this provides the conflict detection mechanism to all project stakeholders that aid in the identification of physical interferences between components and advanced over tradition 2D coordination process. So this allows stakeholders to engage in coordination processes earlier in the project lifecycle. Identifying and resolving coordination issues during the design process in a virtual environment is highly valuable to all the project stakeholders when working with the 3D models. And the common business objectives of using 3D coordination as an identified BIM use are to ensuring that the project can be physically constructed, meeting the original design brief and the function. It can be used for reducing project costs by avoiding having to find costly resolutions in the field during the construction, avoiding the need of a value engineer solutions to maintain project cost, avoiding abortive rework, and also to reducing the project delays. So the benefits of the particular process consists of the 3D coordination process creates a more informative environment for coordination meetings by distinguishing between errors in the models and locations where separate models clash. This shortens the design cycle and improves the quality of documentation produced. The 3D coordination process enables stakeholders to initiate coordination from early stages, preventing major changes to the design later on. Any necessary redesign can be done in small increment due to the frequency of the design coordination meeting. And also, the design coordination process becomes more effective by utilizing a centralized database for coordination issues and their resolution, assignment, and status. Yeah. So basically, this 3D coordination process, the basic disciplines affected, we have to check the coordination between different disciplines, coordination between two or major disciplines, coordination of multiple models within a single discipline, coordination with existing conditions and assets models in a 3D, and even coordination between multiple projects. So in order to understand the entire process, we just need to go through the basic terminologies that need to be used in this particular process. Starting with the BIM execution plan. This BIM execution plan is an exhibit to the contract that captures project-specific goals, processes, and deliverables that will be needed for the execution of a BIM on a project. The coordination process should be considered before a contract is signed, whether there is a regional standard or the client is making a demand for the process. The BIM execution plan is a live document subject to change throughout the project lifecycle, but from the onset should have clear expectations and a project-wide code for conduct for stakeholders. The clash detection is a process that allows for effective identification, inspection, and reporting of interferences in a 3D project model. Tools such as Navisor's Clash Detective tool or even the BIM 360 model coordination module can help a user to reduce the risk of human error during the model inspections. It can also be used as a quality assurance check for both completed design work and ongoing audit checks of project's progress. A clash is considered as a hard clash when the model elements intersect with other model's elements. For an example, when a ductwork is passing through a solid beam, this is considered as a hard clash. Soft clash. A clash is considered as a soft clash when a model element encroaches into the reservations space of one another element. For an example, it is considered as a soft clash when a building envelope intersects with the reserved airspace of an airport, or an inspection door to a piece of equipment clashes with a pipe being opened. So this is not another element in the way, but the space is reserved. And tolerance refers to the minimum distance the objects can intersect before they can be considered as an interference or clash. A federated model is a combined building information model that is combined from several 3D models from different disciplines. This is typically achieved through linking or referencing the distinct models together, so they are visible within the context of the whole project. And finally, the level of development is an industry mapping of geometric and information modeling requirements. So basically, we are using LOD throughout the project, and it can be used for many of the BIM users in a project. And this system of model element definition establishes a framework for model accuracy as well as reliability. For an effective coordination process, sufficient information should be embedded in the BIM execution plan. The minimum requirements that are expected to be the roles and responsibilities of personas, or even we can use the RASI metrics, the file formats and versions of project documents, file naming conventions, project coordinates, the 3D coordination schedule, clash tolerance, and model elements, and the model element exclusions for specific components as well. So this RASI metrics, like any BIM process, it is vital for 3D coordination process as well. The parties involved in the coordination process should be well aware of their roles, responsibilities, accountability, and the way they are informed or consulted with. Creating the clash detection matrix is a mandatory step before starting the project because it documents the goals of clash detection and identifies the tests that will be run in the project. So this kind of clash metrics are used by many of the industries, even in the GCC region. So the advantage of using this one is it is well defined. The standards are priorly defined before starting the clash detection process of a project. The tests defined are selected based on the project type and the project requirements. So the clash matrix created will vary in precision, depends upon the project size and type. The matrix is organized by breaking down first all disciplines involved in the project. And it consists of clash groups and clash priority of the elements assigned, and the sequence of how the clash detection should be happen and to resolve these kind of things are predefined inside the document itself. So each discipline shall be broken down into different categories of objects grouped by types, names, or sizes. And the way a discipline is broken down is generally by the object type, but sometimes an additional granularity is needed. So the project BIM execution plan must include a clash matrix that defines the project disciplines and elements, as well as it is broken based on its disciplines, and the commonly available disciplines should be as architecture, interior or structure, mechanical, electrical, and plumbing. And it depends based on the project sizes and the number of volumes required for dividing the project itself. The clash group numbering system, this must include all the necessary elements that will be part of the clash test and assign the group of elements with a number. So this number can use to help with the configuration and reporting of the clash test in the model. And one important step that we can able to use by at least by utilizing this clash group numbering is we can able to set the search sets inside the clash defining softwares, so for easily identification of the elements which is associated with the respective clash group numbering. Next thing is the clash priority level. A clash matrix shall help identify with the clash test should be performed and in what order they are generally organized by the construction, coordination, priority of building components and systems, etc. The clash solving sequence, it should be also well defined. Say for this example, for most of the project, it will start by resolving or checking the clashes between priority A elements first, A against A, then to B, then to C, like that. So the sequence can be exactly as followed for a well-defined clash test. And erroneous clash testing is also defined in the metrics. So this structured process avoids the comparison of a large amount of elements with other objects in ways that generally results in the identification of a significant number of erroneous conflicts, such as doors with walls or lighting fixtures with ceilings. Such kind of things can be resolved. Most usually in the clash metrics, this is well defined by marking with a cross numbering or with any other type identifier. One important aspect is like as elements are generally required to be tagged with the industry classification system, and the attribute can be utilized to group the model elements during the configuration process of setting up the clash test designated by a project clash matrix. The 3D coordination process during the design will be led by the BIM manager and the design lead. The project manager starts the 3D coordination process either through a scheduled event or at request. The following steps provides an overview of 3D coordination process steps as depicted in the diagram. Uh, the next step is the BIM coordinator retrieves the models as input from the different disciplines via project data repository, and based on the data identified in any EIR, the BIM execution plan, and the MDS as reference and deliverables, all the discipline models and non-model based information is collected and stored in a shared location designated for the 3D coordination. Then the BIM coordinator processed the project information to assemble the 3D coordination models in Navisworks or even in the cloud-based BIM 360 model coordination software. The 3D coordination models are combined as per clash groups and priorities defined in the clash detection metrics. Then the next step is to perform the clash detection. The BIM coordinator runs the assemble the model 3D coordination test based on the information provided in the clash detection metrics and reports the clashes using the agreed upon template. Next step is the checking of model errors in the sequence, and this is a specific decision point. So the BIM manager, in conjunction with the BIM coordinator, decides if the clashes are caused by modeling errors, and if there is, you have to update the models, and we have to do the cycle again. And if not, it can be a scheduled meeting should be processed, and the project manager invite the appropriate stakeholders to the 3D coordination meeting. The clash report is distributed and reviewed by the relevant parties prior to the meeting. A coordination meeting, all relevant stakeholders participate in the 3D coordination meeting. The BIM coordinator will facilitate the meeting and will take the notes on. After that, the BIM coordinator combines the coordination reports with the corrective actions on issues to be resolved as agreed during the coordination meeting. Then the design lead, in conjunction with the discipline leads, assign the actions to the design team and modeling tasks to the discipline design teams to resolve the coordination issues. The discipline leads and designers review the design considering the action items list and revise the discipline models in response to the coordination report. And finally, upon the completion of the revisions, the project manager ends the 3D coordination process. And if needed, the project manager may trigger another iterations of a 3D coordination process until the entire issues has been resolved. So this is the entire cycle which it is preferred, and this continues until all the issues has been resolved from a project. And this is generally used irrespective of the software which is used for the process, whether it is desktop based or whether it is cloud based. Clash avoidance is one important step that we have to follow in order to minimize the risk of the clashes. Minimize the risk of the clashes which is identified at the pre-construction stage. The clash or the interference checking is critical part of the project design development process. If costly, coordination rectifications are to be avoided on site during the physical construction of the project. So basically, this involves three stages: the preparation of the models to be clash free, and the modeling of specific things to be added in the modeling process, and finally the interference checking in the models. This is part of the QA/QC checking of the models prior to sharing with the other disciplinary files. So the basic thing that we have to do for this, the first one is regarding the MEP equipment access zones. So it is always hard to identify the clashes in the MEP equipment access zones, even when by specifying the right tolerances values. A typical example here is an inspection. We can just say that specific access zones to be added along with the MEP components before the model has been shared with the other disciplinary files. So the advantage of using the access zones as a generic model component or using as a mass is within the model authoring software, we can able to check the clashes between the elements which is encroaching this specific zone. Basically, if we haven't created any specific 3D elements like this way, it can't able to identify as an interference between other 3D elements. Next thing is for densely packed services areas. The creation of service zone help drastically reduce the chances of clashes between different MEP services. So a proper service zone can be created either by using the mass or using the generic models. Modelers can always keep their discipline within the proximity of their service zone area. So the benefit of the mass is it will be always hidden in the model views if the modeling authoring platform is using is Revit, and it can be utilized in the Navisworks for checking of clashes between two different service zones. The next thing is the Revit interference check available in the collaboration tab of the Revit allows for quick penetration and tangent self check within one model or between linked and inserted geometry from other disciplines. So the test can be refreshed after geometry modifications to check for the interferences resolutions. So the process of detecting as well as the resolution of the clash in a desktop environment. So the basic principles that I have shared early is basically used. Starting of the project initiated by the project manager, then the creation of 3D coordinations, the clash detection standards to be implemented, then the performing model check for the discipline models. Once it is done, the next stage is the compiling a federated model, which involves the exporting of the discipline models directly from the model authoring softwares and appending the design discipline models into one single environment, basically the federation of the models all together. And once it is done, it can be moved to the next stage, that is the clash detection configuration, which uses the configuration process that involves the creation of the clash, the involvement of clash metrics or sets and templates to be used for the purpose of the clash detection can be configured properly. And once it is done, we can go with the clash detection process, which itself is identification of the clashes, grouping and sorting of the clashes, then to report with the other stakeholders which is involved in the process. And in clash resolution, what we are usually doing is the fixing of the clashes in the model authoring platform, and this cycle continues until all the clashes has been resolved. And once all the clashes has been resolved, the model will be moved to the as an archived coordinated model for using this one for the other project BIM users to end the process itself. For the cloud, for the desktop-based clash detection process, we always recommend the Navisource Manage, which is a file-agnostic platform that can read 50 plus file format and aggregate them in a single view. So the advantage of using the clash detection management engine within the Navisworks is that users can find any design conflicts and resolve them before it reaching the site and cause delays in materials, wastages, and all. So Navisworks consists of three file types. The basic Navisworks cache file. The NWC is the direct Navisworks file, which consists of the raw data that can be exported from the any of the model authoring softwares, say Revit or Civil 3D or any CAD-based platforms. And this can be combined all together as a federated model, and the file type that we are calling it is the NWF, or the Navisworks working file. And that can be we are using all the kinds of operations inside the Navisworks file set, that is the working file, including the clash detection or 4D simulation or even the model reviews. And finally, as part of sharing with the other stakeholders, can able to export or document these files as an NWD format, which consists of appending all the individual NWCs incorporated. So the ability of Navisworks to compile files belongs to different disciplines, helps coordinators and reviewers to process the seamless model coordination process. So the two basic things that we have to be aware of inside the Navisworks environment is the creation of these sets. There are selection sets. That means we can able to select elements for the coordination by using the explicit selections, or what we are calling it as selection sets. And there are more powerful and dynamic options available inside the Navisworks, that we are calling it as search sets. So the advantage of using a clash matrix is, in the clash matrix, we always define model with specific clash priorities and clash groups. And these parameters can be, or these values can be added inside the model authoring software and can be embedded as an information for any of the model elements that can be used inside the project. So the advantage of search set is we can create search sets based on certain conditions and formulas, like an element belongs to this specific clash priority should be considered as a priority A elements. Like that, we can able to create specific sets, and it can be used as a template to be used for any kind of the projects. So once we have the Navisworks models, so these kind of templates can be basically utilized for the clash detective purposes. So the basic templates that we are using are the clash, the search sets, which is available as an XML file, or we can able to predefine the clash test, and it can be saved as a template for using for another projects. And even we can able to use the template for modification of the visibility, to control the visibility of the model elements inside the Navisworks, and using the appearance profiler, and this template can be saved as a .dat file. So basically, Navisworks can append all project disciplines in one single environment to create a federated master model. And these master models can be used for many different purposes, including the clash detective process, so that all the views which is created inside the model authoring software will be preserved inside the model itself, so that we can go and review or even create markups, or we can check the measurements on the model itself. And then comes the power of creating sets inside. So basically, in Navisworks, we can able to use the search sets using the manage sets option, and we can able to import the search set as a template to be used for any of the projects which is involved. And once the search sets has been added, so this is very dynamic. You can able to select the elements based on specific conditions or values which is defined inside the clash test. Selection of specific elements based on specific values. For example, clash group belongs to the foundations or ceilings, can be selected even in one click, and these kind of sets can be incorporated inside the clash detection templates as well, so that priority A elements against priority A elements, we can simply incorporate by using the element selection will be happened basically by using the right search sets. We can have an example over here. So in Navisworks, we have a powerful clash detective tool sets available. So the use of we can able to simply import the clash test, which can be saved as a template, as a file, can be used anytime in a project. And even once it is done successfully, we can able to save this one for the other projects as well. So inside the template, the predefined clash test will be available. So even if I'm selecting one specific clash test, the right elements which belongs to that particular test will be identified. This is basically based on the values defined inside the search sets, and the elements can be identified at the very pre-construction stage. For the resolution part, we can able to use the element identification numbers based on which is very unique for each and every elements in the project model involved. So if we are checking the clash detection process in a cloud-based environment, the overall scenario is not changing. Basically, the platform is the only thing which is changed. The process will not be changed. It starts from the instruction of the project manager who will initiate the process. And the next thing is from the project BIM coordinator or BIM manager level, they can able to create the BIM 360 project with the model coordination module if they are using. Then the next step comes to the part of project admin who can able to create the folder structures specifically for the clash detective process, and they can able to set the coordination spaces as well. So once the spaces has been created from the work in progress project models, they can simply share that one to the coordination spaces, and they can able to select the different disciplines based on the requirements of the clash test, and they can perform the clash detection process. So the clash detection process here is very much automatic. So the clash between different disciplines will be charted well, and the coordinator or the BIM manager can even group and visualize the clashes, and after that they can able to move the clashes for the resolution purpose from the modeling team. And this process continues till the clashes will be resolved from the project model itself. And once it is done, the project will be moved to the archive space for the other BIM users. So basically, we are recommending the BIM 360 model coordination, which is a cloud-based model coordination package, which provides a coordination space to upload, review, and detect clashes between the latest set of project models. It is integrated with the BIM 360 environment. It leverages the permission system of BIM 360 document management with the automatic clash detection within the designated coordination spaces. So the basic principle of working inside the BIM 360 model coordination module, which involves three distinct set of personas to be involved. First one is the part of a project administrator who will be responsible for creating the coordination spaces and uploading the models to the coordination spaces. So the BIM manager or the issue owner, he can able to view the models and clashes, and he can have a decision point here to check or to classify a clash as an issue or as not an issue. So in case if it is classified as an issue, then he can assign his team members or project BIM coordinators or the BIM modelers to view the issue or to resolve the issue. And that once the issue has been resolved, the project team members can mark the issue as answered, and the review and there will be the review changes. And if the clash is resolved, they can able to close the issue, or if not, the BIM manager can reopen the case again, so until the entire process will be getting completed and the issue is resolved. So this is basically the environment of BIM 360 model coordination. The project admin can create the coordination spaces. They can able to select the specific folder structure for creating the coordination process. Once it is done, they can invite their own project team members to work on the clash detective process. So the clash detection process here is very much automated. It will be shown like a matrix over here, like the clashes between the two disciplines will be charted, and the clash numbers has been shown over there. And the project team members, they can able to select the different disciplines, and they can view or name it as a regular clash test or weekly clash test, or for a weekly coordination review, and it can be published with their team as well. So once a coordination process has been initiated, they can able to check the clashes between the two disciplines and they can able to check how many numbers of clashes will be there, and they can inspect each clashes in particular. So once a clash has been identified, the clash the issue owner can have the options to assign it as an issue or assign it as classify it as not an issue. So if it is classified as an issue, he can particular project informations will be automatically assigned to the issue dashboard, and the BIM manager or the coordinator can assign his team members with the enough informations, to whom the issues should be addressed, what will be the due date, such kind of informations can be assigned and sent to. So the advantage here is the project team members, they will get a real-time notification through mail, so that they can be hyperlinked to the specific issue part of the project, so that they can work on it to resolve the issue on time. So the process consists of creation of adding services for the clash detection process inside the cloud by adding the modules of document management and model coordination, creation of the coordination spaces, and visualizing and grouping the clashes, and then to categorize the clash as the issue or not an issue. The report and discussion of the outcomes, which comes to the part of clash resolution. And if we can discuss this one in a desktop environment, the goal of clash resolution is to report the output of the results of the physical interference between the building objects. So the generating reports involves after the clash analysis and grouping, the clash results have been published. The publication could be done by generating the clash reports from the Navisource in an basically we prefer the HTML tabular format, or to generate the clash reports as a viewpoint, and the file can be saved in an NWD format to share with the other stakeholders. So although users may be reviewing the models in different NWD files, their resultant files can be merged into a single Autodesk Navisource file with any duplicate geometry and markup automatically removed. And when merging the multiple NWD of NWF files that each comprise the same reference files, So the Autodesk Navisworks manage only loads a simple set of combined models along with all the review markup informations in the merged file. So the data regarding the reviews and markups will not be lost if we are merging the combined all the NWD files all together, and we can use this NWD file for the clash resolution meeting part. Coordination meeting is one important step for the entire process. So there are key aspects to be considered in this part. The first one is the cycle of the coordination meeting. The cycle of coordination meetings may vary from one project to another. It's based on the volume of things to be added in the project, but usually it will be 1 or 2 weeks cycle works well. The BIM coordinator assisted by a technician may lead the coordination meeting. The schedule meetings, send invites to the appropriate stakeholders, ensure the availability of the meeting room and its technical equipment to be able to project on screen the 3D federated model for review of the clash issues. Uh, Participants, basically the BIM coordinator, there will be technicians or discipline model managers or professional design needs to be involved. These are the recommended participants for a clash meeting. And for the preparation of the coordination meeting shall be prepared by the BIM coordinator for the project. And the presentation usually consists of the ensuring the publication of clash reports prior to the coordination meeting. And it is recommended to have these reports ready by 2 days prior so that the receivers will get enough time to review the highlighted clashes by their own, and preparing of a hard or electronic copy of the class report to be given to each stakeholders prior to the meeting. And one important thing is in Navisworks, verifying the 3D views that will be presented during the coordination meeting are clear enough to make all participants understood the issue. And the last part is all the decisions that are made during the coordination meeting can be documented directly in the Navisworks by adding a comment to the clash and actions assigned. So this is one specific option which is available inside the Navisworks manage to make the model archive. And resolving the clashes in the host model depends upon the type of model authoring applications which is used. So one important part is if the model author is using Autodesk Revit, there is a switchback functionality available. So the switchback enables one to select a particular object in the Autodesk Navisworks and then locate and zoom into the same object in a native model. Authoring applications such as Revit or using the switchback gives the stakeholders the option to fix the issues real time during the coordination working meetings. So there will be some other model authoring applications which the designers might be using, so, such as AutoCAD Civil 3D. So the switchback functionality will be available in that application as well. And all the elements which is created inside the Revit or Civil 3D, there will be a specific element ID available. So this can be used for tracking elements even after identification of the clashes. So switchback functionality is one specific option available. Apart from that, inside the Revit or inside the Civil 3D or any of the Autodesk applications, the element ID or the entity handler numbers can be utilized for the identification of the elements at the time of model authoring itself for resolving the clashes. And there are some specific BIM productivity tools available on market which can be used for the resolving clashes issues which is relevant for the purpose of the creation of the builders opening. Like AGA CAD, they have a specific module called creation of the cut openings will identify the clashes between piping or ducting elements with the structural elements like floors or walls. Then it will automatically create the void space which is required for the smooth transition of the particular model elements in a very short time period. which can save considerable time in the modeling aspect. So once files are updated to resolve the clashes, the updates need to be coordinated back with the federated model. Following the process set up by the BIM manager, the updated model should be delivered as required and uploaded to the project delivery data repository in the same method as defined for the first delivery. For the clash resolution of the cloud, there are two specific particular processes available. The first part is identifying after the identification of the clashes, to report the team who is involved in the resolution of the clashing elements. So like said before, the creating issues options available inside the cloud-based clash detective process can be very much utilized for this particular purpose. Creating the issues and addressing the issues to the project team can be effectively utilized over here. And once the issues has been created, the total overall report of the issues can be generated from the web-based application itself. So issue reports can be taken anytime, or it can be scheduled in a weekly basis or a monthly basis based on the project requirement. And the BIM 360 model coordination module itself contains a meetings option, and this can be effectively utilized for creation of coordination meetings within the team itself without any time delay, and the process can be entirely coordinated altogether. So what are the business values that we are getting or achieved from this particular process? These are it. One is the operational efficiency, the risk reduction, improved sustainability, and the business growth. And in specific, if we are taking the case of operational efficiency, a well-coordinated workflow starts with a good coordination, good collaboration, and identifying issues early in the design process reduce the need of a repetitive premature review process and rework, and it provide a safe environment for the people. Basically, identifying the coordination issues sits in the heart of managing risks on site. Like prefabrication enables off-site quality controlled manufacturing of parts in a safe environment. Considering the aspects of the risk reduction, a complex design requires a higher need for tight coordination between disciplines to ensure seamless and accurate integration of systems. Identifying issues early in the design process reduces the need of framework or rework and mitigates error before they arrive on site. And reducing the number of errors has been a direct impact on a company's reputation and potential litigation scenarios. Construction is an industry with one of the highest impacts on the environment. So better coordination would increase the efficiency and reduce the energy consumption. It reduces the wastage by ensuring the errors are detected before the construction begins. And coordinating on-site activities will reduce the fuel for the duplicate or inefficient tasks. Considering the business growth aspects, being recognized as an best help establish you as an industry leader and fuels the future growth. And use of a well coordinated virtual model to support the value engineering of the design as well. So here I conclude my session here, and thank you for attending today's session. We are happy to get engaged with you with more other webinar series as well. After the session, you will receive a feedback survey request. There we mention our future webinar programs of this year as well. You can check your interested program so that we can schedule it based on priority. And now we can just move to the Q&A session, and we are inviting your queries.